Hi everyone, I wanted to do a quick video. My 2400 class suggested, hey, it might be easier if I did videos for explaining what we are doing for the various assignments. And for assignment 1 and assignment 2, there wasn't enough to really have a full video about, or at least it didn't seem like it was necessary. However, assignment 3, we start to actually write some code. And so I wanted to go over some of the things that you're going to be seeing and how we're going to go about doing it. So the idea is we're going to do some very, very basic math calculations. Why? Because we haven't done conditionals yet. We haven't done functions yet. We haven't done a lot of the any kind of looping mechanisms yet. And so we'll get to those soon enough. But in the meantime, we're just going to do some basic math. And not overly crazy math, just high school, junior high school geometry math. So first of all, we have a pseudocode question as usual. That is included in the reflection. Like last week, I just would like to have a bit more practice with pseudocode just to make sure people realize how important it is, because in the past I've taught it and people went, okay, pseudocode done, and now I'm going to dive into code. No, always plan your code before you start typing, right? You want to have what you're going to do before you actually go and start typing things out. Right now you don't need to do it right here, but as soon as things start becoming complex, a pad of paper is your best friend. So here's what we're going to be doing. You're going to be submitting a single CPP file. That is your code that you're going to be looking at. I'll show you an example in a second. You also include in your reflection, you'll also have part of your PDF reflection would be your pseudocode. So it could be a photograph or it could be you typing something out. I like writing on paper myself. And so those are the two different deliverables. The pseudocode is a nice, hopefully not that crazy of a problem, and hopefully it makes some sense. So we're just going to be looking at how we could see which of a group of students in a table have problems in the class, and how you can actually identify those students by going through columns or rows at a time. Fine. And I found the problem easier if I broke it into sub problems, like, is this student a problem student or a concerned student? And then I do that for each student, and I'm good to go. So if that would be a subroutine, a little tiny, another pseudocode problem that you could just call or refer to. The other part of this program is going to be looking at basic functions and variables. And so what we're going to be doing is I've given you instructions on what you're going to be included in your file. So here's the various standard files you're going to be using, standard includes that you're going to be using. Here's you're going to be having a main. I'm going to show you that code in a second, and then you're going to be typing out a bunch of printf statements just to see how things convert when it comes to numbers. And then you're going to be doing some math calculations. Fine, like calculating the area of a circle, the volume of a cylinder. So I'll also need another variable for the height of the cylinder called cell height. I think volume of cylinders, the variable I'm going to be saving it as cylinder height, CYL, cylinder height. There's a lot of abbreviations because computer scientists are lazy. And then we're going to be calculating the volume of a sphere with incorrectly a bunch of different times, and then correctly, to see how the math works and how things change depending if I'm doing integer arithmetic or if I'm doing double arithmetic. The type of variable changes how I do the math. And then finally, I'm going to have less exact details, a bit of a review of what printf does, and then a more open-ended calculate the volume of a cube. Okay, and so here is the kind of starter code we'd have. You don't even need this standard file, but I left it in there anyways. So you can leave it in, you can take it off, it doesn't matter. We have a bunch of include statements that you're going to be typing in. I'm going to make a constant double, meaning it is a double, but I cannot change it. It is hard code. You're saying my pi is this number, and it is always this number. So if I want to use the number pi, I don't have to remember what pi is, or I don't have to remember to a certain number of decimal places. I can just hard code in a value, but I don't want to just put in 3.14159 a bunch of different places. I want one variable, or constant, even better, because it's not going to change. I want a constant that I can just refer to everywhere. So every time I need pi, I say my pi, like here, rather than typing in 3.14. I never hard code in values. If I hard code in values, it's normally like this. I make a constant and then I refer to the constant, so that if I change the constant, it changes everywhere. It is absolutely bad form to hard code in values most of the time, simply because it will eventually bite you. Okay, so here's a printf statement, fairly simple printf statement. So I just took one of the printf statements that we were going to have. So my pi is an exponent, as an exponent is, and then here's an e for exponent. It'll output my pi as an exponential number. Okay, as in like 3.14 times 10 to the power of 0, I guess. Okay, and then we're going to be making a variable called diameter, a variable called radius, a variable called cylinder height. So 3 different variables. And then we're going to also make variables for when we calculate like the area of a circle. And so instead of 0, I'm going to be doing something. I'm going to calculate something. It might be like, instead of 0.0, it maybe it's diameter times diameter. It's not this, by the way, times my pi. Maybe that's the calculation. It's not. But how do I calculate the area of a circle? And so I calculate the area of a circle. If I change the diameter to 1 now, then my calculation for the area of a circle is different. My calculation for the volume of a cylinder is different. And then I'll have a bunch of printf statements at the bottom for each one of these things, so I can see what the output is. We're also going to be dealing with breakpoints. So here is me making a breakpoint. I just click on this gray bar on the side here. Boom, I have a great breakpoint. This means it'll stop I can go right here, I can run things. All right, and now I've broken right here. Here's my console window. I can go one step at a time. This would be this button right here, step over, F10. And I can see what the heck this is. I've got to look where I am. Okay, I'm on this line right here now. I can see what diameter is. I can just hover over it and see what the value is. It's a really, really big number. Why is that a really, really big number? Oh, wait, it's not initialized yet. If I go one more step down, F10, now it's equal to 1. And this is why we had to look at binary at first. Okay, and just in case you're wondering or curious, my pi as an exponent is this times e to the power of 0, as in e to the power of 1, 10 to the power of 0 or 1. So therefore, it's 3.141590. I'm going to be just what you want to be doing while you're coding this, in case I haven't been saying it enough. First of all, plan beforehand. Do a little bit at a time. Compile, test. Do a little bit more. Compile, test. Do a little bit more. Compile. The last thing you ever want to do when you're coding is write everything all at once and then go compile and see if it works. Compilation does not mean it works. Compilation means that you have something that potentially could work, but it's the same as saying I started my car. It's the same as driving on the highway. No, not really. You need to start your car in order to drive on the highway, but it's far there. That's a very different thing, right? Driving on the highway is a lot more elaborate. There's a lot of things going on, but the first step has to be to start your car, right? I need to compile, then I need to test my code to make sure it's working, and so I can see what kind of output I get here. So in this case, it's going to, let's find out what this is actually going to spit out on for me. All right, and oh, I did one thing wrong actually. Let me fix that while I'm at it. The circle diameter is 1 with an area 3.141590. That doesn't seem right, but that's something to think about. Okay, and if I just continue, I should get one of those. There you go, close. Here's what I missed. This function returns a value. We're going to be talking about functions very, very soon. By default, it doesn't force me to do this, but I really should, like return 0. I want to return something. The reason I have a return value is maybe if something goes wrong with my program, I return a -4 in some other program or some other application. uses that information. Maybe it returns 0 when everything's fine, 1 if there's a problem, 2 if some other problem happens. It allows me to output or send back out potentially useful information. Most of the time, we're not going to make any difference, but that's the reason why some of our main methods or main functions have an int. So if I have an int, I should return something. Okay, that's all I really wanted to go over. We're going to be going over again in more detail in the synchronous lecture as well. I presume we would at least. And I'll make sure on Fridays we're going to be having, I'm going to be posting or sending an email about all the things you're going to be doing for that week, just to hopefully make things a bit more synchronized than they've been so far. And this is just one of the things that you can look at, the videos for the assignments, to help explain things. Okay, thanks everyone. Talk to you later.